Good afternoon. My name is Gordon Borns, and I'm Chairman and CEO of Borns Incorporated. In fact, our company is celebrating this year our 70th anniversary, and we have been in Riverside for most of those 70 years since 1950, when the city of Riverside moved my parents, Marlon and Rosemary Borns, and the 7 families that were working with them from Pasadena to Riverside. And so Riverside has been our home ever since 1950. And in fact, though my parents started in their garage making parts for the aircraft industry, with only about 7 employees for the first couple years, today our company has 15 plants around the world, about 6,500 employees. So we have shared with the students that if they have some good ideas and work hard, that they can grow their ideas and make a business like my parents did, starting with the garage. So this has been a fun week of STEM in law enforcement and public safety. We call it STEM Leaps. And our focus this week has been on the fire department and EMT. And we've had some tremendous support with especially Chief Moore from the fire department, and Orrin Pence, retired Assistant Fire Chief. Orrin, would you raise your hand? Oh, yes, right here. And so we thank you very much for your tremendous support. In fact, Chief Moore and Chief Pence are both judges, and I'd like to introduce the rest of the judges too. So Gina Perez is also with the fire department, in charge of the CERT program, and that's what we were certified in earlier this week, the Citizen Emergency Response Team. And so Gina, thank you very much for your support. We can hold our applause for the very end. And then we have, from the Riverside Police Department, Deputy Chief Larry Gonzalez. Chief Gonzalez, thank you. And from Riverside Public Utilities, we have Sharon Gutierrez and also Damaris Velez. So Damaris, thank you very much for joining us. And in fact, we are talking to Riverside Public Utilities about the opportunity to do something similar that we've worked with on the police department and now the fire department. This is the first year for the fire department, and that we'd like to do something with the Riverside Public Utilities. Because when you think about it, Riverside Public Utilities, of course, provides our water through most of the city of Riverside, and our power, the infrastructure. I think you have also a lot of fiber optics too, the what we call the dark fiber that is just waiting to find applications. So there are tremendous opportunities to apply STEM for Riverside Public Utilities. And then from Riverside Unified School District, we have Patricia Locke Dawson, who is the Vice President of the Board of Riverside Unified School District, and also Ron Weston. So Ron. And from Riverside County Office of Education, we have Yami Shimojo, who's a STEM coordinator. And from UC Riverside Graduate School of Education, Henry Shimojo. Henry, thank you. And Dwayne Nelson, who's Nelson Patent Law and a member of the Riverside CEO Forum. So Dwayne, we appreciate your being here. And Mayor Bailey should be here very shortly. I understand that he is bearing, unfortunately, some back pain, and so he may be just a little bit late. So but let's give a hand to all of our judges. In your program, and I hope you all have programs. If not, we've got some extra copies over on the tables. But we have a list of all the students, and we thank our students and each of the teams that will be presenting today. Also, I would like to recognize a few other people, too, who have been just tremendously helpful in this preparation. In fact, on the back of your program is a list of all the Riverside Fire Department personnel who have assisted, beginning with Fire Chief Michael Moore and Gina Perez, and of course Chief Orrin Pence. And as curriculum managers, John Robertson, in fact, John will be saying a few words here momentarily, but John has worked with Warren Pence and Gina Perez and I on the fire program. And for the police program, Angie King was tremendously supportive, representing the police department too. So Angie, raise your hand wherever you are. She's probably out making sure things are going smoothly. We also had yesterday tours through UC Riverside's Bournes College of Engineering, named after my parents, Marlon and Rosemary Bournes. And starting with June Wong, assistant dean there. We had a great program yesterday with some of the sponsors from the IEEE, Guadalupe Ruiz, Jacob Poole, and Cody Simmons. And then from UC Riverside School of Medicine, we had Kathy Barton, assistant dean, together with various second-year medical students host us yesterday. So we really appreciate the great experience we had at UC Riverside. And I want to give a special thanks to a number of people here. My assistant, Lindy Reneker, and I'm not sure if Lindy's in the room here, but she helped put the program together and has kept us on schedule, took care of a lot of the public relations on this. And Steve Klock in our marketing communications did the graphic work, the program. And then Carlos Morton is one of our mentor students. And Carlos, would you raise your hand? Carlos was one of the winners from last year. Also, Madison Eason was a winner from last year, a student mentor this year. Pardon? Oh. Well, your spirit was a winning spirit, okay. And then Mario Orendane was also a mentor for us this year too. And Kevin Curry. Kevin, would you raise your hand too? Kevin he's part of the PIC group leadership group in Riverside, and he's been helping us tremendously throughout the week as a mentor and helping with the presentations too. So, and finally, on your program, we list all of the sponsors at the bottom of the back page that without this, we couldn't have done this at no cost for our students. So Motorola Solutions Foundation is a lead sponsor, also Wells Fargo Bank, Riverside Police Foundation, Bournes Incorporated, Vocademy, NAVC Warfare Center out in Corona, Riverside Unified School District, Coffee Bean, Brilliant School Apps. Mary Barnett did a class on apps at our first week. Innovation and Learners Engagement, ILE. Chipotle provided lunch today. Panera provided lunch on Tuesday. Snacks throughout the week. Chick-fil-A provided lunch on Tuesday. Esri provided software that we needed. And then CTE from Riverside Unified School District was key too. So, John, let me introduce you and have you come forward to say a few words too. Mr. John Robertson.
Thank you very much. Just very briefly, I just want to point out the great work that is happening here as a result of a partnership that is supporting our schools and our public system. And it's a partnership between the municipality, industry, and our public school system and our private school system in the case of our police week. So I just want to point out that this could not happen without the great support from our community and the collaboration that we all participated in. So I would like to thank Mr. Bournes for the great work and great leadership and great collaboration that you've provided us. And without further ado, I think we should get our program on the go here and begin with our presentations. So it's the Scouts first? Okay. Do you want to come in? That was your cue. Come on, up you get. Thank you, Erica.
Hi, I'm Erica Zubia. I'm the Health Academy Coordinator over at Ramona High School. So I'm going to announce the student teams. Their team names were decided amongst themselves. So if you're, as parents, wondering where they came up with this, you can ask them later, or they may even describe it in their presentation. So our first group for the afternoon is going to be Scouts. Come on up. And then just to mention, students, as you come up, you'll come up the side as they are. Stay on the stage. Parents, you'll have an opportunity to take a photograph with Mr. Bournes and the students and some certificates that they're going to get. And then prior to them starting, we just want to mention that the panel will be asking questions. Unfortunately, the audience members, you will not have a chance to ask questions. Thank you.
Hello, I'm Cato Davis, the CEO of Scouts Industries, and I'm going to be, my coworkers will be introducing themselves.
Hi, I'm Julian Castaneda. I am secretary.
Hello, I'm Jonathan Fielder. I am the Community Relations Manager.
Hello, I'm Alexandra Stepp, and I'm the design engineer.
Hello, my name is Luis Morales, and I am the treasurer.
Okay, so we have a device, and before starting to show off our device, I just want to let you guys know that our main goal of the device is to protect our firefighters and the users. So I'll be showing, he'll be describing what the device does, and I'll be showing it off.
So the device here is
We'll switch. Okay, the device, it is a pulse monitor, a location tracking, and body temperature monitor. So show them how we would. So first, the device would be clipped on the internal straps inside the helmet, as he does that. And then we'd put that on, please. Okay. And see, now as he puts on the device, it's a little straight, but okay. As he puts on the device, the device will be monitoring his pulse, his body temperature, and his location. So if a firefighter is in a fire and then he has a really high heart rate and his body temperature is over the dangerous amount, then whoever is monitoring the device, so the temple would be monitoring the pulse on the temple, and the person outside would be monitoring on some type of device their pulse, their location, and see if they're okay and everything. The safety officer. And now we're going to be passing it off to the designer.
So to have a better look, we have a 3D model right here, and the sensors are right here. These are to monitor your pulse, and right underneath is to monitor your temperature. And right off to the side is the little GPS tracker. And the entire device will be encased in a durable type of plastic, much like the materials that firemen's helmets are made out of. And just to ensure that it will stay on, this entire front piece would also have an adhesive that will stick to your temple. Okay.
All right. The summary of the cost is the bill of materials. The GPS would cost $1. The pulse reader would cost $10. Heat monitor would cost $20. The hotspot would cost $25. Overhead costs $6. Estimate of the total product costs $62. Selling price, we as a company have decided to set the price at $120 for each device.
And I will be discussing the products plan. Okay, so within 5 years of us finishing testing, we would like to roll it out to the Riverside City Fire Department and CAL FIRE. After 3 years of testing, or not testing, but trial, we would get feedback from the firefighters and see where we could improve on the product and what's good. And during that time, we would also be trying to roll it out to the rest of the state agencies. And after about 15 years, we would like to make the product nationwide to all fire agencies in the United States. And we are also considering making it usable for search and rescue operations and paramedics.
So this is Officer Tran. Oh, this is Firefighter Tran. He passed away in a fire He passed away in a fire due to exertion and during the line of duty. And
Okay. This is a firefighter Tran. Sadly, firefighter Tran has sadly passed away due to a heart attack while fighting a fire. This so we've been told that the heart attack may have been caused by his heat temperature and his heart being overexerted. So we were thinking that maybe if our device was implemented, maybe firefighter Tran could have been saved and probably prevented and been seen in medical attention before his heart attack. So I'm Cato Davis. Thank you for being here and listening and having your opinion on your device. And here's Julian Castaneda.
Special thanks to Mr. Borns, Chief Pence, RUSD, Angie, and Gina, all the judges, and everyone who could make this event possible.
Any questions? Okay, thank you. Okay. Him first, please. We looked online, and as we were scrolling down, there's multiple GPSs that are they're just like small. They're all different. It goes from a price from $100 to even $1. It's just where you got to look on the internet to buy them. And there's chips, little small chips. So, any other questions?
What is the maximum temperature the device will handle?
Since we are using a very good material, we're going to probably have at least maximum temperature of 175 degrees. The device will communicate to the safety officer. The fire truck will have sort of like a hotspot device that will implement signals like Wi-Fi type signals out to the building, and then they will connect to the device, and they'll transfer information back and forth.
It was 8 years, and I'm just wondering why you chose 8 years. It was 7 for the whole state and then 15 nationally. And how did you come up with that, and what was the deciding point for that?
That was actually an error I missed, and I thank you for pointing that out. But wait, can you repeat the question, please, so I fully understand it?
Why did you choose 8 years to roll out your product nationally?
Oh, okay. For it to be nationally, we want to make sure that it's completely how to put it. Okay, sorry about this. Okay, but okay. So we want to get feedback from other firefighters first and other firefighter agencies first in the state of California to see if how we can improve before we send it nationwide. To make sure at its peak. Any other questions?
What is the expected battery life of the device?
You got this?
The expected battery life of the for the device is 8 hours because we're gonna be using the same batteries that they use in the like maybe phones but less dangerous. So once you're done with your shift, go in, clock it, charge it in, and then boom, it's ready to go the next day. Any other questions?
One last one. Looking back at the entire week, what parts were you most excited about? What parts were most proud about? Everything you guys accomplished this week.
Being up here and doing the slides because we were the most nervous about this, and I hope we're doing decent.
Any other questions? All right.
Sophomores and the freshmen. And so I am here to read the names off of the participants of each team. And so as they are given their certificates. So Scouts, the CEO is Cato Davis Roots. The treasurer is Luis Morales Aguiar. The design engineer, Alexandra Stepp. The community relations manager, Jonathan Fielder. And the secretary, Julian Castaneda. So this is our team Scouts. Good job, gentlemen. Back up. All right. Do you want me to just introduce the next team? Okay. All right, so for our next team, we have Ferrum.
Sorry, we're having Hi, my name is Jacqueline, and I just want to say thank you to all the judges and audience that were able to make it today and to hear our projects out. I just wanted to say, throughout this week at our START internship, we were given the opportunity to look upon the ideas and perspectives that every emergency responder has given us. We got the chance to look that every day is a new challenge, every day is a new obstacle to face, and they were able to give us a perspective on it that they still need help and we need to find ways to help them and make it faster. And I just wanted to say thank you to Mr. Borns and the School of Engineer and the School of Medicine, and thank you all the judges for today, and I hope you really like our project. Oh, and this is our CEO, Daniel Ramirez.
Thank you. So my notes got deleted, but I guess I'm just gonna go off of what I remember. Okay, so I am CEO and partial designer for Ferrum Enterprises, or Enterprise, sorry. Today we will be presenting Project Enthalpy. Our goal, my team and I, we will be our goal is to present to you a robot that is supposed to help with an early warning system, and it'll help improve what the emergency responders do. And we'll be showing you the design right now. And to do that, we'll have Hostiel and Richard.
All right. Hi, my name is Richard Serrato. I am one of the lead designers for our project Enthalpy. So first of all, I'm going to start off with the camera. We were thinking of a CCTV camera, which is highly fire resistant and also which has great or excellent camera quality. We were thinking of going to this camera. Can you show the camera? We were thinking of using this camera in our robot because this camera can withstand heat temperatures of 518 degrees Fahrenheit without having major malfunctions, and also not have a lifespan. We were also trying to make sure that this camera was installed with different optic lenses such as infrared and thermal to look for and search for victims. Next off, I'm going to start off with the battery. So the battery that we were planning to use is a lithium iron phosphate battery, which has a lifespan of almost 11 hours, which is quite fantastic. Also has a 3,300 watts and also 3.2 voltage. So what that means is that pretty much it lasts long. But this battery specifically is actually very good for the environment. Most of them are used in electric cars. They're just bigger. So this battery is quite fantastic. All right, I'm going to pass it off to my associate, Hostiel Garcia.
Hello, everybody. So I'm going to present to you the design we made. And basically, okay, the red thing is a drone, the actual robot. The purple thing is a top view and a front view. That's the top view, and this is the front view of where we're going to put like CO2 cans and like maybe put some extinguishers, something small. Moving on. That's the side view of the robot. It's a prototype, so we can fix it later, but basically we use a triangular shape because it's a strong shape, and it looks cool too. So we're going to be using a remote control just like this, where it has, oh, my bad, so camera right there, right? These are going to go right here. So we're going to use a remote control right there that's going to connect to the camera, right, like with the display, to be able to locate people inside of house. Let's say if you have an earthquake, so you can go inside. Instead of sending a fireman or a CERTS member, we can send this drone inside to check for people inside the earthquake, which is a building that's collapsed. We're going to have like GPS, infrared cameras, all that sorts of good stuff. And the material we're going to use, the metal, is called Inconel 600, and it's costs about $3 per pound. And okay, so this thing right here, when you go inside of a building, the fire, it has like a cap of smoke, and that can go up to about 1,100 Fahrenheit. And this bottom white part is where our drone's gonna be, and that's about 400 Fahrenheit. So we use this. Our metal can withstand 2,300 Fahrenheit. So in case we get a flashover, it can withstand that kind of heat. And for tires, we don't have fireproof tires yet, but we're gonna extend our research and try to make these kind of rubber, something with a flexible material that's not that that doesn't have a high, that has a high melting point, and we're gonna create these that don't have air, and it's flexible too. So yeah, and that's Jennifer.
Good morning. My name is Jennifer Avalos. I am the sales engineer. So basically, what I do is I work with customers and users, which will be you guys. And so basically, I show how different our product is from others. So basically, what the robot is, since there's so many out there, is that not only is it waterproof, but it's fire resistant. It has live stream video for you guys to watch what's going on, and it also helps people in earthquake disasters, and the services I will be selling this to will probably be military services, private industries and companies, and also fire services. And basically, the people we worked with at UCR was Jim, which was the lithium battery, which Richard talked about, and was Cody Simmons, which helped us with the wheels and the circuitry. So of course, we will need a lot of improvements with the help of you guys. And as is, we feel like Enthalpy does the greatest good for the greatest of numbers. So thank you. Do you guys have any questions?
Thank you all. It's a wonderful presentation. I heard you talk about the tires are not completely fire resistant, but can the robot go upstairs?
We're trying to install that. We're trying to modify the tires just like the SWAT teams use. They can their tires are modified so where they actually push up through the stairs and they can actually elevate the robot. So we're trying to modify those tires.
Okay, thank you.
Any more questions?
Okay, yes, thank you guys so much. So I think I may have missed this one. Is the robot or the drone also fireproof? And
Yes, that's why we put the Inconel 600. The Inconel 600 is a very durable, very fire-resistant metal. Actually, Mr. Bournes actually recommended that metal, so we actually looked it up. Actually, did some research, and we actually chose this as our frame. So we're gonna hopefully put the metal around, we will be going to put this metal around our robot, and it will go through fires and withstand high temperatures. Any more questions?
Hi, very good job again.
Thank you.
Can you tell me a little bit about the monitoring device and how you'll receive the images that
We were thinking of you wanna?
Okay, sorry about that. So we all thought about that maybe inside your guys' fire truck, you guys can have a monitor in there. And with that monitor, you will put the address of where that fire is at. And then from there, that little robot will give you a full report of how many victims are in there, where the fire started, how long has it been been burning for. So you know how some firefighters have been falling through roofs, and it does really suck, and I feel bad. But that will help you knowing how durable the structure is, so you guys don't put your guys' lives at risk, because obviously your guys' lives is very important. And also what it does is, what else does it do? Oh yeah, it just gives you a full report of everything, and yeah.
We also plan on having it send a report to all surrounding businesses and other operators in the area, so that the businesses, and also civilians, sorry. It'll be like an Amber Alert, and we hope that'll prevent other fires by surrounding buildings. Thank you. Any other questions?
Yes, we got 2 more.
Hi guys, I like your project. First question, is there a meaning to the title of your project, Enthalpy?
Enthalpy is the title of the robot itself. And what I learned in chemistry was that it was the change in temperature, and so temperature, fire. And for our name, Ferrum, that's iron. The robot is going to be strong, so strong like iron.
Okay. Second question. Have you considered any heat effects on the battery performance?
Yes, we have, and we looked into some coolants, and we got some recommendations from Borns. Where's he at? We got some right over there. We got some recommendations from Borns, and we also did some research on our own. Do you have more on that?
We were thinking of, what was it called?
Electrothermic cooling system.
So this electrothermic cooling system would most likely be placed around the batteries and the wheels, so that in case of overexposure to heat or heating up way too much, because this battery only goes up to 518 degrees Fahrenheit before it starts malfunctioning, we were thinking of putting the electromagnetic coolant. Okay, we were thinking of putting the electromagnetic coolant around that. Oh, thermoelectric I can't say it.
Thermoelectric. It's called the thermoelectric cooling system.
Yes, that. Okay, I can't pronounce that. My speech is off right now. But yes, we were trying to put that around the wheels and the battery to preserve the life a lot longer in case of overexposure, cool it down.
And the thermoelectric cooling system uses something that's called I believe it's called a Peltier effect. So yeah, it uses that to extract the heat from the robot.
We also plan on. We also plan on having it being surrounded. They'll be surrounded by different materials such as ceramics, and then Nomax, which is used in firefighters' attire, and then so that should also protect it.
Any more questions? Okay. All right. Thank you for having us. The cost? We're hoping the cost will be around $7,000 to $9,000, because we were looking into the cost of it. So we're trying to make it very cheap by finding very cheap metals such as the Innocell or Inconel 600, which is $3 per pound. So it's quite cheap to surround this object, and we were hoping to make it at least 1 foot by maybe 4 or 5 inches, roughly, so it can fit in small doorways, small little collapsed shelves in case they fall. So roughly $7,000 to $9,000. Is that all? Or is there any more questions? My bad. I'm sorry. That sounded very rude. I'm so sorry. I'm so sorry. Okay. Thank you for having us.
Okay. Chief Pence, Gina?
I'm just going to read your names off. Okay, so our first, hello, did you turn it off? So our first participant today is Daniel Ramirez. There you go. Just step up forward. Go ahead. Our next participant was Richard Serrato. Our next participant was Hasiel Garcia. I can't talk. Our next participant, Jacqueline Herrera. And our last participant in Ferrum is Jennifer Avalos. Pictures. All right, thank you, students. And our next group presenting today will be JARS Tech.
Good morning. Hello. I want to thank all of you judges for coming out and being able to give up your time to look at teenagers' ideas. Who does that anymore? But we are the future, and so we have to look forward to that. And I'm glad that you're here. I'm Ryan Reyes. I'm the CEO of JARS Tech, and this is my team. I'd like them to introduce themselves.
Hi guys, I'm Zoe Sturgeon. I'm the secretary.
I'm Vanessa Almendarez, the treasurer.
Hi, I'm Andrew Silva. I'm the community relations manager.
And I'm Temi Jakinyefa. I am the CTO.
Does anybody know how many firefighters die every year? No? Okay, about 120 firefighters die every year. And in the past 20 years, about 900 died. Our goal is to minimize that number, and so we created Eyes Above, which is a multifunctional drone that lowers the risk of injury by sending it inside heavily damaged or moderate damaged or any burning buildings, and just keeping firefighters safe, like by mapping out the entries and exits that they can go in and make their job a lot easier and faster.
So the Eyes Above drone will have a camera utilizing night vision, which will allow it to see in the dark. It will also have a sonar system sending back a 2D image of the surroundings of the drone. It will also have 2 canisters full with ABC dry chemical to alleviate the fire somewhat, being activated and dropped on fire parts, and aramid fiber and thermoelectric cooling system will make the drone fireproof, of course. And because burning buildings, visibility is a problem. So what we did is we made a 2-way vacuum, which will pull in smoke, filter that smoke, and push out fresh air, then increasing visibility for the camera to then be able to move.
So what makes this drone efficient? What makes it better than just slapping on another camera onto the drone and sending it inside of a building? Well, let me give you a scenario. What if firefighters come to a building and it's on fire and they want to get inside the attic? And so they send in the drone, Eyes Above, and it's safe, but then all of a sudden the fire comes through the floor because all the other floors are on fire. So the drone with 2 aerosol cans full of ABC chemical, dry chemical, drops one of them, and it pushes the fire, it puts out the fire. It doesn't put out the entire fire, but it makes it so that the fire is put out in the attic, so it's able for the firefighters to get in safely and do their job. And so by the end of the day, they'll be all safe. And that's the main point of this. Have everyone be safe.
Okay, now to talk about expenses, but first to expand what Temi said on the aramid fibers. It's actually a fiber that's fireproof and fire repellent. So we will wrap this around the drone, and it will just protect the organs of the drone. So it could withstand 1,000 degrees Celsius and 1,800 degrees Fahrenheit. So the price for that would be $12 per pound, and for the actual drone itself, it would be $1,000. The sonar that we will get, it will be $50. The canisters, the ABC dry chemical, it will be $10 for 16 ounces, which is 1. The vacuum that we'll use, it will be $40. The thermal cooling system, it will be on $35. And the night vision, which is the camera that has like a clear vision for any time, it's $50. But the total will be $1,200, which is, I think, a worth it price. And if you have the possibility of saving lives.
Okay, as Andrew said, the product cost will be $1,200. Then the sale price would be $1,560, and the profit we would make out of it would be $360.
So the Eyes Above drone can be used in a multitude of situations: search and rescue, disaster situations to find victims, burning buildings. This will both decrease the casualties but increase efficiency and speed of the job. Also save lives, and as Vanessa said earlier, 120 firefighters die a year. We believe that the Eyes Above drone is the way to decrease this number, because that's what matters, the lives of the firemen. Thank you for your time. Any questions?
Two questions. By the way, nicely done. What are the dimensions of your drone?
We were thinking something just a little bit smaller than an average house doorway, so it can fit in through windows and, get the job done. It also can't be too small, or else it won't be able to carry its load, but not too big, or else it won't be able to fit in anywhere. So,
That is my next question. What's the carrying capacity of that drone?
carrying capacity would be enough to carry both the canisters, and the battery would last for about 27 minutes. So the battery would help increase the payload that it could carry.
To add on to that, we were thinking, to give an exact, probably about a pound and a half worth of payload. It's not supposed to go very far, but it's also not supposed to be really light either. It's not supposed to just peter out. As soon as you lift it off, it's but yes, it does help having about at least a pound or a pound and a half worth to carry in case you need to come back and then put more on and then send it out. So yeah, I hope that answers your question.
Yes, and my last question, by the way, nice sound effect.
Yes. I at least try to add some
That was good. That was good. Last question. You talked about the canisters of carbon dioxide, right? Or anti.
It was ABC dry chemical.
ABC dry chemical.
So it'd be able to put out most fires set within a house. So yes.
Okay. Now, is there specific wrapping around that specific canister in order for that device to not explode with high temperatures?
We were thinking more of a detach system, like a button on it, or it would just be able to, whenever it gets close to heat, it would just drop off. So I know that aerosol cans can kind of explode around 300 degrees Celsius. So that so it'll just blow up around whenever fire. So that's why we want to drop it into it, so it can go in and drop into the fire, into the base flame and explode. It wouldn't really help if that kind of blew up on the thing, on the drone. So yeah. Yes.
Who's the person that will monitor this, and then what is the receiver or monitoring device again?
Any firefighter would be able to pilot the drone. It doesn't really necessarily need a special person to drive it, and the camera on top should be where they'll be able to see. So the camera will be placed on top, and the camera should be on the controller for the firefighter. So they should just be able to look down at their control. So. Thank you for your time.
So you students can stay right there. After you get your certificate, probably everyone else, we're going to try a different system. So you stay right there. And, Chief, you can be over by Cynthia. Okay. And Lauren here. Okay. And then, so you students can shake our hand and go down. Is this one of the certificate? Of course, it's the first one.
Okay, so our first participant of JARS Inc., was it? Tech, sorry. Ryan Reyes.
Congratulations.
Thank you. Congratulations. Thank you.
Our next one is Temi Jekanaya. Our next participant, Andrew Silver Sanchez. Our next next participant, Zoe Sturgeon. And our last team member, Vanessa Almendarez. Thank you, Jars. Pictures.
And now some pictures. Maybe all the photographers could get together so we look at just one place. Oh, did we pass out all the certificates?
Yeah, that's it.
So cheese. Cheddar or what? Riverside Pride. Right? That's right. Yeah. Riverside Pride.
You good? All right, thank you very much. All right, and our next team up is Marsh Labs.
Hello everyone, we are Marsh Labs and we are here to present you a new development in child safety called the Baby Bubble Bracelet. And this is our team. I am Daisy Arteaga and I am the Chief Executive Officer.
I'm Celine Murillo and I'm secretary. I'm Isis Roman and I'm creative director.
I'm Leslie Hill and I'm financial advisor.
I'm Paul Shepard and I'm the president and market director.
So I'm going to explain the dangers of heat exhaustion. What is heat exhaustion, you ask? So heat exhaustion is when a person is in a hot environment for too long and their body can't cool itself down. So me and my team, we researched, and from 1998 to 2014, 636 children died from a vehicle heat stroke. And in this data, you could see how it's just increasing every year. And I have a short video to show you guys. So in that video, you could see that heat strokes is like leaving your kid in a car can really cause some problems.
So our mission here is to decrease the number of babies that die yearly of heat strokes from being left in a car. Also, we want to provide parents and caregivers an extra precaution to improve the baby's safety.
Hi, I'm Isis, and I'm going to be talking about the design that we all came up with and what it includes. It would include a Bluetooth sensor chip, which would be integrated, and as my partner Paul just gave, so you guys can pass down, that's an enlarged version. We would have the chip integrated and a digital thermometer sensor, which would detect the car's temperature, and it's made out of thin silicone, which makes it waterproof. Babies put everything in their mouth, so no drool would be able to destroy anything inside of it. Parents and caregivers will also receive a bracelet too, so that way it's connected with the baby. How it works: the bracelet contains a unique code that is linked to an electronic profile where you can provide a picture of your baby, if your baby's allergic to anything, and an emergency contact. It's waterproof. You can choose how much information you want to put about your baby, any allergies, any medications that your baby's taking. It has an alarm to warn the parent about the child's safety. So you can go 100 feet away, and it's going to start sending an alert saying you're forgetting your child in your car. That would also be, you could also get all that connected with we're creating an app, which that's still in the progress, but that's going to be coming shortly. But that would help for you to stay connected at the same time. And it's also rechargeable. It comes with the charger. The battery lasts 12 hours, so you can charge it overnight. And pretty much, we're just trying to make babies stay safer.
These are the prices of our product. The rubber silicone is 50 cents per unit. The digital thermometer sensor is $6 per unit, and the Bluetooth is $150 per unit. The total is $8, and we're selling this product at $50. That will include a set for the caregiver and the baby, and the profit made out would be $36.
Social media and websites are a great, low-cost, and efficient way to advertise a new product. Currently, we are developing a website that will let users read our mission and get to know Marsh Labs better. And we also will, in the future, we'll have future developers be able to make it able to purchase the item and review our item. And in today's society, social media is key in advertisement. Social media outlets like Snapchat, Instagram, Facebook, Twitter lets businesses put out advertisements for free. This will save Marsh Labs a lot of money, and the extra money we make from profiting will be going towards research and other and the community to make child safety development research better. And you can connect with us on Snapchat, Twitter, and Instagram at Marsh Labs.
So we just want to thank you guys for everyone who can make it, and also the judges, and for your time to hearing us out on our idea. And thank you. Is there any questions?
The video you showed was showcased pretty well the problem, and thank you for approaching the problem. And so how did you get the idea, the concept for the baby bracelet?
So while we were doing our training for CERT, we had many guests come in, and firefighter chiefs and everything. So they started giving us ideas. They just kind of saying problems that they were going through. And one of the main things was babies dying because of how hot it gets in Riverside. So we were thinking, why can't we help them reduce that number down with something creative and also cheap?
Any other questions?
I have one. Oh, that video, boy, it's really powerful emotionally. I have to tell you, that was a good grabber. Two questions. How did you come up with the name Marsh Labs? And secondly, could you envision this working with, say, an iPhone watch or something, an existing technology, or what is the exercise one,
Yes. Well, Marsh Labs was created because it spells out the initials of our last name. So since we wanted to make everything like as a team, as one. And yes, we could see that happening. Right now, we are in process of trying to develop an app where you can register both bracelets to the app, where you can also either disable it when it's not in use, and also you can take or add more information which you would like.
A good presentation, thank you. Just real quick, a scenario, if, let's say your monitor went off, and luckily we were able to save the baby's life, and but there was charges pressed against her for child neglect. Would we be able to use this tool and book it into evidence? Would you guys be able to stand by that if it came up in court in some way?
Yes, you would, because we're setting an alarm off for 2 minutes tops, maybe 3. that the parent has to get to the child that's in the car, and if the parent doesn't get there in the amount of time, emergency contact will be contacted. Like, we will send it to 911.
Okay, great. Thank you.
Thank you. Any other questions?
Do you want this mic or the one that's up there?
Okay, thank you, Marsh. So our first participant today, this afternoon, is Isis Roman. Our next participant, Leslie Hill. Celine Murillo. Standalone guy, Paul Shepard. And our last team member is Daisy Ardiaga. Thank you, Marsh Labs.
You might mention Daisy was our CERT leader.
Oh, yes, just in our training on Tuesday and Wednesday for CERT, Daisy was selected as our team captain. And on Wednesday afternoon, when we had to do our final test, she was the one that ran the whole program and told us to go do triage or to go do search and rescue or to do the different things that we need to do to pass this test, that we had put out the fires, all the things that we had to deal with in an actual emergency. So she did a phenomenal job. We all survived. Well, no, I'm sorry, 2 died. 2 of our CERT members died, not because of her fault, but because they didn't remember that they had to stay with their partners. That was one of the things we had to learn. You always stay with your partner. All right, so she did a phenomenal job. So thank you, Marsh Labs.
Did we have all the pictures taken? Okay, very good. Excellent. Good job. Next team.
Okay, our next team, MAMI, or are we doing the initial acronym? I don't know if it's MMA, MME, or what is it, MAME, MAMI? MAME. Okay, this is MAME.
Hi, good afternoon, everybody, and thank you for all coming, and especially the judges. My name is Anthony Garcia, and I'm the CEO of MAME, and our motto is "Every second counts."
So you might be asking yourself, what do these kids have for us? So we have invented, well, we want to upgrade the EKG machine so that it has retractable wires, because on Monday morning, 2 of our team members, Anthony and Ever, were at an EMS station, and during that EMS station, EMS told them that they had problems with the wires getting tangled. So what better way to save time to untangle the wires than retractable wires?
Hi, my name is Ever, and we feel that this will help EMT responders respond more efficiently because it saves valuable time. When they're in the back of the ambulance, they don't have time to worry about tangled wires and like trying to find out which one is which. They don't have time for that. They're trying to focus on saving their patient. So we decided to make the wires retractable with also LED lights.
I'm Monica. And I'm Maria. And as you can see in the picture up above, the ECG cables are all tangled up. Well, in our upgrade, the cables are going to be organized.
Okay, so we are gonna have a lock system similar to a retractable dog leash. And say if a patient tries to take off the ECG cables, the lock would be able to keep it in place so that cables don't go back until you unlock it. It would be able to retract.
Okay, so I'm going to tell you guys a little about what it's made out of. The retractable box is going to be made out of bioplastic because we found out that bioplastic is a affordable material and it is not cheap. It won't break over time. The leads, the casing, is going to be 3D printed using strong, flexible material. Upon completion, we will get together with an engineer and figure out materials that would work best. The leads are going to have color-coded LED lights embedded into them, so it's easier to tell which one is which. And the ECG machine itself will not be changed at all, because we found out that the material already has a 6-foot drop-proof guarantee.
Good afternoon. My name is Melissa Garcia. The estimated expenses for this upgrade is about $4,500 due to the cost of the LED lights is $5. Average cost of the ECG is approximately $2,000 to $4,000, but we're not trying to recreate the whole machine. We're just trying to upgrade for the cables. The retractor wires cost $100. The bioplastic estimated is at $50 per barrel. The sale price is $5,000 and the profit would be $500. We would advertise this product by going to hospitals or clinics and making posters and having it out in hospitals and clinics. So we would also have a website set up, so it would have all the information on it.
So, in conclusion, I just think that this would be a great upgrade, and it can help a lot of people and a lot of EMS people. And just think, if one of your family members was injured or anything, you would want them to get the best care in the fastest time. So every second counts. Thank you, everyone, for coming, and the judges especially. Any questions?
Just wanted to clarify the $5,000 would be for the cables themselves, standalone from the EKG machine.
Not really. The $5,000 would be the sale price for the EKG machine with the wires, our new and improved wires, put into them, installed, instead of the wires that they have now.
Thank you.
Thank you for your presentation, guys. Do you have any data about how much time is spent or wasted with the wires currently?
Not really, but when we were talking to, I can't recall her name right now, but she said that it takes them like a good 20 seconds to really figure out and untangle what is which. And when it's retractable, everything is just right there, and it's just easy. They don't get tangled because you can unlock it and then it goes right back in.
Question is about the 3D printing. How did you select 3D printing for the production device?
Well, actually, I did it. I thought of that idea because I just thought 3D printing would be easier and somewhat cheaper than other ways to produce it.
Nice presentation. Were you able to determine what would be the kind of wires that you would be able to include inside those specific pieces that you're planning to change?
We just plan on like keeping the same wires, like the in itself, the ones that actually, send the information to the machine, from us, to keep the same wires, but just the outside material itself.
And also embedding the LED lights into the wires that are already there and made.
Any other questions?
Okay, so our first participant from MEM today is Monica Banos. Our next participant was Ever Ryan Lenarte. Our next participant was Anthony Garcia. Next participant, Maria Perez. Next up, Melissa Garcia. And our last participant on this team is Mariel Alvarez Olvera. Okay. Thank you, MEM. All right, our next group up is Monorex.
Hello, everyone. Just wanted to say thank you for coming to Borns' facility and taking your time to come to view our presentation. I'm the CEO of Monorex Enterprise. My name is Alex Gradilla.
Hello, my name is Richard Ortega, and I am the sales manager. My name is Matthew Zuvi. I'm the CFO of the company.
I'm Leonardo Rodriguez. I am the secretary.
And I am Cameron Burciaga, and I am the designing engineer.
So over the past week, we've been working on a project or enterprise known as REX. Stands for Recognition EKG 10. It's basically a standard EKG in a way. It functions like a standard EKG. You may be wondering, why are we making an EKG just like any other, or almost like any other? Well, this one has a bit of modifications. Some of the modifications it has would help EMTs avoid any tanglings of the 10 leads on the 12 lead, from the 12 lead EKG. Along the way, it would retain much more, a sanitary environment for patients and EMTs, and as the day goes by. It would diminish the overall size of the EKG, and over time, of course, it would bring forth an incentive for forthcoming biomedical technology.
Okay, so today I actually have a model for you guys to view. If Matthew, can you please pass this down? And what the new type of accessories we have for the EKG is a techno support AI. It comes with the normal things that an EKG would have, like a mini thermal printer and attachable automated external defibrillator pads known as AEDs. And it also has installed retractable leads, touchpad monitor with disposable touch pen, a gurney hooks, mobile app access, iPhone or tablet adapter, a heart simulator, and Bluetooth pairing. And we also have a video for you guys to show a small demonstration of what I mean. Now, it's not going to be exactly like that. It will be more of to where like a screen projector to where you press it down, it would lock it on its own, and then when you press it back up, it will retract. Now, this is a design we found, which is kind of a representation also as to what we want. It will be connected to the EKG, and within inside of it, it will have the retractable device somewhere in the middle. That way, it can be safely installed into the EKG, and it's not loosened out. It keeps it well protected, and it keeps it organized. And also, it allows for the AI to give feedback from the body and give a suggestion to the operator as to what's happening to the patient. And it can also you can also change the settings of the AI to tell it the certain age and the gender of the patient. Because you know how there's different blood pressures, different heart readers out there, so it will help get a more effective and accurate reading.
As a company, we chose to put an AI system in our product because we feel like it'll make it more easier for the paramedic or an EMT to work and have an efficient way, an easier way to work with their patients. An EMT would be able to utilize their phones like an Android or iPhone to give Lars, which is the name of our AI, to give it commands to do what it could do. Lars would be linked through Bluetooth, which would also be connected to the EKG, and that's how they'll be able to communicate with each other. With our newly improved EKG system, we would be able to send heart waves throughout the body, which would then tell Lars if there's any abnormalities to the to the patient's body, so then it'll notify the EMT or paramedic that there's something wrong with the patient. They need to assess it as quick as possible.
So this is just a basic example of the system networking of how it's going to function. As you can see, there's a monitor which points to a tablet. That tablet will have an app which runs a Bluetooth integrated app. That app will allow you to communicate with the AI on the EKG. And from the tablet, you'll have the ability to verbally catalog information about the patient, perhaps send it to a computer as well. And from the tablet, you could also verbally command it to print the heart waves. And now Matthew will show you the costs.
So current AKGs right now are between $25,000 and $30,000. Within reasonable saying that the EKG we will develop is at an affordable price. However, it will have many features that the current AKG doesn't have. The EKG that we are creating will help firefighters, paramedics, and EMTs better their job, and when their training has to consist of this part as well. It will allow them to learn the AI system. Here's some of our costs right here. The rechargeable battery would be around $150. The thermal paper rolls would be $5. AI would be $1,200. And then going down the list, you see the prices there. And our final production price would be around $7,662.
So as my colleagues were already saying, that Rex will be pretty much the future of EKGs for our next generation. And Lars, which would be the AI system, it would actually be a separate cost along with the EKG. So when it comes to, if you would like to integrate the whole Lars, the AI system, the voice activation, you're looking about a cost about $12,924. And if you would just like the whole EKG that would just have the built-in retractable wiring, just with that on its own, that would be about $11,724. And what we're trying to do is that I will be marketing the product towards paramedics, EMTs, and almost every first responder medic that would be available to use this, to operate this machine. And then we would also like to hopefully brought out into the military as well for the military medics. And that will be all. Thank you.
Any questions? Also, thank you to our mentors, all the teachers, and most importantly, Mr. Borns and the judges. Any questions? Thank you.
Here's the question. We hear that there's a huge problem with wires when
Correct.
it comes to electrocardiograms. Is there a possibility that that your team would look into actually, instead of actually in a wire structure, create a wireless structure?
We were actually looking into that, looking into the whole prospect of this. We wanted to have a non-wireless system to where it just connected into the EKGs. Well, non-wireless meaning you wouldn't really notice the wires. You wouldn't really see the wires. They would be inside the system where you would pull it out. But after you're done with using them, they would go back into the machine showing none of the wires at all.
So would you be able to only have it with a wire process, not necessarily using a Bluetooth or some kind of a signal that would go from the electrodes into the machine that would read it?
The Bluetooth that we is this working? Oh, the Bluetooth that we acquired, I forgot to mention this, but it's for operators to connect to their phones in case of scenarios to where if they can't listen to Lars correctly, they can use their phone as like as a way to listen and to speak to Lars. And the wiring to the adapter is in case if the Bluetooth is not working, like if you're in a wild area. And with the wires, it would be possible if we're able to still be placing the wires onto the patient and giving the proper shock to them.
Have you done anything to examine the durability of your product?
So we have looked into the durability of the wires. We have looked into pretty much everything during making this project. We have found that the cords are easily snapped. We've also found that when they get tangled, that's when they start to degrade, and that's when they start to degrade.
All right, thank you, Monorex. Our first participant is Matthew Zuvia. Our next participant, Alex Gradia. Our next participant, Richard Ortega. Next, we have Leo Rodriguez. And last, Cameron Burciaga. So thank you, Team Monorex. All right, and our next group up is Safety Bomb, Inc.
Hello. Oh. Hello. Oh. Hello. Good afternoon. I want to thank you for the opportunity to speak to you and present to you our idea today. So, we are Safety Bombing Corporation, and our motto is "Because You Matter." I am Giselle Gonzalez, and I am the sales management.
I am the CEO, Sarah Cabral.
I'm Alexis Bird, the secretary.
I'm Haley Freeman, the design engineer.
I'm Michael Lamone, and I'm the treasurer.
What is RMP? RMP is an acronym for Release Monoammonium Phosphate. RMP is a throwable fire extinguisher that releases gas, well, it's cylindrical, and it has vents to release gas and suppress fires in commercial buildings, residential homes, and including attics and cars. RMP is going to be 8 inches long and 2.5 inches wide. It is made out of magnesium. Our product will contain 800 milliliters of monoammonium phosphate.
How would we integrate this into the police department and the fire department is first we would integrate it into the fire department's procedures and processes. And then we would start putting it into the police department. Everyone would have safety training to use this product safely and effectively. and it's not going to be for the general public.
Okay, so how this is going to work is the gas inside the container is pressurized. So you would pull a pin that would be right at the top, just like a normal fire extinguisher, and it will activate the device. And then you would throw the device directly into the fire, whether it be in the car, whether it be in the attic. And then there will be an external detonator that someone will push, and it will release the gas. We did make these refillable, so on the top there would be like a little hole, so you would put it over the gas nozzle when you buy the gas itself. And then once it fills up to its capacity, then it will automatically seal, making sure that nothing will escape.
The problems that RMP solve are during our CERT training, many of the firemen came over and showed us videos of firemen falling into the roof of houses. And I was like heartbroken. I was like, oh no. So what we did is that we got the idea from that by going on top of the roof or going anywhere and being able to make a hole and throw it. And we can throw as many as we can to like minimize the fire or put it out completely depending on what the size is. And it like reduce, and like you can go in once the fire is minor or there's like none at all to go see if there's anybody inside, cause you matter, like you lives matter. So that's what it solves. Oh, and it puts out A and B fires and not D and K fires, or yeah.
So some of the impractical uses of our product would be on Class D fires or K fires, chlorine fires or oxidized fires, or around sensitive equipment, because the retardant is not meant to put out these fires. But with enough research, we are hoping to be able to make a product that would be able to put out these fires. So the costs to make our product would be, we would use magnesium for the shell, and magnesium costs about 35 cents per 100 grams. A monoammonium phosphate, which is the retardant, would cost about $60 for 25 pounds of it. Our remote controller could cost about from roughly $50 to $150. To make our product, it would cost about $502. And hopefully we can equip all fire trucks with our product. This would cost the city about $14,000 to equip all fire trucks. And if we are able to equip all fire trucks, we can make the community safer and lives of first responders safer, because you matter.
Thank you for your time, and any questions?
Great presentation, thank you. Just a quick question. You talked about having a separate detonator, right? I'm just thinking of an attic fire, and the firefighters, I know when we go to calls with them, they're dressed up, they have an apparatus on them. If I'm a police officer and I throw this up there, is this something where I would need an apparatus, or am I okay, because we don't carry those?
You would be fine, because it's throwable, so you can stand from like a length what you think is good, and you can just throw it inside if there's like a hole or something, and you can just detonate by yourself. It won't like blast, but it'll just like have enough pressure for it to like be able to make a small boom, and then like all the gas would come out.
I wouldn't have to worry about breathing any of that in.
No, because it's not recommended to breathe it in, but it's like safe for you to be able to do it, to like breathe it.
Thank you.
Okay.
Thank you guys for your presentation. Thank you for showing the limitations of your product. So you described nicely the D and I think K fires, but can you tell us a little bit about A, B, and C fires? What are those?
So A, B, and C fires are general fires, like it could be a trash can fire, or maybe wood, or certain oils or chemicals. A, B, and C would cover those, but for specific ones, our product would not put them out.
Like your presentation, I like the title. How does it work? So what is the chemical reaction that actually takes place that puts out the fire?
So just the pin, we would put like sensors in it in its memory. So once the pin is pulled, it would know to be ready to release it. And so once it gets into where it needs to be, the heat would actually kind of trigger it off. So that way it knows that it's not like in a, just like a normal day. It knows what it's going to do.
Question on the use case. So a firefighter enters a room or is about to enter a room, and there's a fire blazing. You deploy this device. It's got 800 milliliters of the chemical, which I can't remember. What's the expected outcome? What do you expect to have happen next? Is it going to put out the fire? Is it going to reduce the heat? What's going to happen?
So what it is, it's like a fire extinguisher, I guess. So you'll be able to, not only you can carry multiple. So what it does is that you'll just like throw it and it'll go off, and with enough, not too much pressure and not too little pressure, that it will just be like enough for it to like slowly, like when you okay, you know how fire extinguishers, you like push it, like it would be like that type of force, I guess. And so when that happens, it'll just like, minimize it or put it away, if you like, depends on how many you have in the building.
Okay. From the 3 legs of the fire triangle that you learned on the first day, which leg is this going to extinguish or cause the extinguishment from?
Can you repeat it?
Of the 3 legs of the fire triangle, heat, oxygen, and fuel, which leg is it going to remove?
It would mainly be focused on the oxygen leg, but if it, so once the oxygen is gone, it would then cover the fuel surface of the area so that it would kind of take out 2 in 1.
All right, thank you, Safety Bomb Inc. And so our first participant this afternoon was Haley Freeman. We have Giselle Gonzalez. Sarah Cabral. Micah Limon. And Alexis Bird. That's everyone. Okay, thank you, Safety Bomb Inc. And for our last presentation of the afternoon, we have Smog Inc.
Good afternoon. Before we start, I would like to thank everyone in this room for giving us all your support, and especially to the judges and mentors and everyone who helped out throughout this whole week. I am Jocelyn Sanson, and I am the CEO of Smog Incorporations.
Hi, I'm Stephanie Garcia, and I am the Secretary of Smog Incorporation.
Hello, my name is Elizabeth Melendez, and I'm the designer engineer.
Hi, I'm Sarah Megan, and I'm the marketing manager.
Hello, I'm Natalie Olmos, and I am the CFO.
So to start off this presentation, I would like to show a video. So in this video, it will show a risk that firefighters risk like on their daily lives. So this is what inspired us to further out develop the design that we created. Okay, so who you saw, the firefighter, was Captain Dern. He suffered 3rd and 4th degree burns, which was approximately 70% of his body. With our new design, this could have been prevented. So our model shows a ladder that at the end, it would be able to be stable. Well, it'll give the firefighter stability and also be kind of flexible, which we named the Flex. And this would be, it would hover throughout the surface of the roof, and it would not collapse in case the roof collapses, it would not go with it. So it would give stability to the firefighters.
Okay, so our goal with the Flex, which is our product that we have created, is to prevent more tragic incidents from happening. So when we were at the fire training center, they said that they want every one of the firefighters to go back home safely, and that is one of our goals as well. But we also want to have the firefighters be better equipped so their jobs could be a lot more safer and a lot more easier for them. And we believe that with the Flex, the ladder, that the firefighters will be able to do their job without complications, and that their attention will be fully on the fire, and their attention will be to extinguish this fire as fast as they can, and all their people will be safe. So with the Flex, the ladder will be able to adjust to the roof. If the roof is flat, it would be able to go down flat. It's not going to be on the roof, it would be hovering over it. In case the roof collapses, the ladder would be there to hold the firefighters up so they won't go down with it.
So me and my team had several different ideas of creating a complete new ladder, but we decided to instead do a chip. This chip allows the ladder to move in different directions instead of going up and down. Not only will it have a chip implement, but it will have a mechanical structure at the end of the ladder that will help stabilize the firefighter in order for them to, to move it. Our design isn't to make something super complicated or drastic, but to use your technology to improve it so it will help minimize the risk factors of our firefighters while saving as much money as possible.
Okay, and on to funding this project that we have. There's many grants available to firefighters so they can improve their equipment. As you all see here, it's all an application that they fill out and then wait for it to be approved. And for our project, we would start off with a 3D printing model that has a chip implemented in it. That way we can see if it works, and then move on to testing the product, and then have our final product.
So the materials we would be using is a chip and a mechanical structuring, which is made out of aluminum. The product cost would be $700 for the chip and about $2,000 for the aluminum that would be used for the mechanical structuring. Our selling price would be $3,500, and we are trying to make a profit of $1,500.
Okay, so to conclude, we believe that every firefighter should be able to go back home to their loved ones, and that has become one of our goals, like I said in the beginning. That's why my team and I have created the Flex, as we call it. And the Flex, it's very flexible, like I said, to all the different types of roof, and we believe it would be very helpful. And we believe that with this ladder, we can save many lives with one ladder at a time. Thank you for your time. Any questions?
With the ladder being flexible, how would you get it to be flexible if it's, I believe I seen made out of aluminum, and how would that work?
Well, when we went to UCR, we asked a couple of engineers to explain to us what type of metals could be flexible, and they told us if aluminum is really flexible, but if to use a lot, it'll have a lot of durability and it will not be flexible like as bending, but it will be easier to move.
And then one other question, just the chip, explain how that operates again and what's the purpose of the chip?
Okay, so we plan on having at the end of the ladder kind of like a control for the firefighters to be able to control the ladder and move it to whichever position they need it or angle they need it to be.
Okay.
Any other sorry.
Yes, thank you, ladies. And any thought about how much weight or how many people can the ladder hold or sustain?
So normally the firefighter's ladder right now could stand 750. Like we said, we don't want to make something completely new. It would be able to sustain about the same weight. Any other questions?
Yes, if we were to look at your diagram where you're going to have that structure of the ladder,
Yeah.
and you're looking at a specific bracket that would be able to hold on as an extension, as a horizontal extension of that angular ladder. Have you looked at the possible weak points in which you would have maybe a structural effect of fire or weight? So is there weak points in your ladder based on weight or heat?
Like we said, it would be able to sustain the same weight, and of course there will be like a brake to hold it in place or a lock to hold it. So we believe we're like still making it better we're trying to see how it would be able to lock in a way that, because the whole point is for it to lock so the firefighters could walk upon it like a platform. So like, may I say it's like a platform so they could walk and not fall. So yes, there would be something there to hold it in its place. Any more questions?
Would your product be applied to new apparatus, or would it be retrofitted into existing apparatus?
It would be in the existing because, again, we're not really trying to make a complete new ladder. We're trying to make it improvements.
All right, thank you, Team Smog. So let's get through Sarah Megan, our first participant. Elizabeth Melendrez. Natalie Olmos. Jasmine Sanson. And Stephanie Garcia. Okay, thank you, Team Smog. Let's give everybody a round of applause for all 8 of our teams today for coming in and doing their work.
So our judges are now going to deliberate. This is going to be a very tough decision to come up with a first, second, third place winner from these 8 great projects. So while the judges are deliberating, which could take as much as like 15, 20 minutes, we have some refreshments set up over here. And Josh Berry, who's been our AV operator. Josh, raise your hand back here. Josh, thank you for your help. Josh is going to show some slides and also some videos taken by a drone of this past week's activities. So enjoy, and we'll be back in 15, 20 minutes.